Today we're working on section 6.4. These notes are in your student journal on page 171. Our goal today is to be able to graph exponential functions with transformations. So what is an exponential function? Well, we've been talking about these. This is when we have y equals a to the x. A is not allowed to be 0. If it's 0, then we're just left with y equals 0, which would just be a horizontal line. The base has to be a positive real number other than 1. The reason for that is because if our base is 1, 1 to any power is just going to be 1. So that would result in just y equals 1, which would be another horizontal line. So that's why when we have an exponential function, we have these restrictions that a must be some number other than 0, and our base must be some number other than 1. So transformations, we've been talking about these throughout the entire course. I'm not going to go through these in depth. But if we have an x minus 3 that's replaced our x, that's going to be a shift to the right 3 units. Let's take another one. If we have our original function of y equals 4 to the x, and we have a minus 1 at the end, that takes us down 1. If we replace the x with a negative x, that's going to be a reflection of the y-axis. If we put a negative out in front of the function, that's going to create a reflection of the x-axis. If we replace the x with a 2x, that's a shrink by a half. If we replace the x with a 1/2 x, that's a horizontal stretch by 2. These are both horizontal. And then if we have a number up in front, this would be our vertical stretch by 3, and this would be our vertical shrink by 1/4. So we're just going to graph some of the basic functions to start with. So if we have f of x equals 2 to the x power, what we want to do is test a couple of points. I want you to test -1, 0, 1. If we do 2 to the -1 power, well, that's 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the first, that's 2. These are what we call our key points. These are going to help us to graph the function. So I'm going to plot these points. At -1, I'm at 1/2. At 0, I'm at 1. At 1, or at 2. Now I want you to think about this. Is this function ever going to cross this x-axis? Think about if x were -100. Well, 2 to the -100, that just means 1 over 2 to the positive 100. So that's just going to be a very, very, very small number, close to 0. But we're never going to get a negative answer for f of x. So therefore, this is going to look like this. Our exponential function y equals 2 to the x power is going to look like that. This right here, this line that it does not cross the x-axis, that's called an asymptote. In fact, it's called a horizontal asymptote. We're just going to call it an asymptote for now. And the equation of that asymptote is y equals 0. And we're also asked to find the domain and range. The domain on this, we can use anything, -infinity to infinity. Our range is going to be, we start at 0, go up to infinity. And it's never equal to 0. It's impossible for an exponential function to equal 0. Looking at this on the calculator, we just wanted to take a look at it, 2 to the x power. Here's the way the function looks. You can see that no matter what x value we use, we never go past this. In fact, if I wanted to sit here and hit trace, and if I wanted to hold my finger here, the whole entire bell that we're in class, you're going to see this y get smaller and smaller and smaller. Eventually, our calculator doesn't even know what to call it because it's going to just get so close to 0. But see what it's doing right now? It's just using scientific notation. Okay, so if I pick up my finger right now, it's at 5.64 times 10 to the -7. Well, 5.64 times 10 to the -7 is just, move this decimal over 7 places, is 0.00123456. That's what the number is. So now you should see that we're never going to get into the negatives. All right, let's look at this function. So what happens if we go from a base that is greater than 1 to a base that is in between 0 and 1? Okay, in between 0 and 1. Then what's going to happen? Notice again up here, the base isn't allowed to be negative, it has to be positive, and it's not allowed to be 1. But it can be in between 0 and 1, like this one is. So what happens in that case? Well, let's make our chart. So we're going to check for some key points, negative 1, 0, 1. If we do 1/2 to the negative 1 power, well, that just flips it over, so it's 2. If we do anything to the 0 power, it's 1. 1/2 to the first is just itself. So here's what we get. So let's look at this function. So at negative 1, we're at 2. At 0, we're at 1. At 1, we're at 1/2. This is going to look like so. Again, we're never going to cross that x-axis. So you can see that this and this are just a reflection over that y-axis. They're exactly the same function, but this one is a reflection over the y-axis. If you think about it, what's another name for 1/2? It's 2 to the negative 1. So do you see what this ends up being? It's really, this function right here is the same thing as 2 to the negative x. Well, 2 to the negative x, remember our rules? If we replace x with negative x, it's a reflection over the y-axis. So that should make sense. Why this function is just a reflection of this function over the y-axis. Our asymptote is going to be, again, y equals 0. And our domain is still negative infinity to infinity. We can use anything. And our range is from 0 to infinity. Okay, let's look at some other examples. We're not doing logarithms, so skip over page 172. And let's do some problems on page 173. It says describe the transformation of f represented by g, then graph each function. On your homework, it's going to say the same thing. I don't care if you graph the first function, you can just graph the second one. But here's how we need to do this. We're going to make our x, f of x, and g of x column. All right? Here's how it goes. You take those key points. Negative, I didn't need this to be so long. Negative 1, 0, and 1. If I plug in negative 1 into this function, 6 to the negative 1 is 1/6. Anything to the 0 power is 1. 6 to the first is 6. Well, my g function is exactly the same, but everything is getting shifted up by 6. So all I have to do is add 6. Add 6. Add 6. And so now I'm going to be plotting these points to graph my g function. So let's see, how do I need to go to 12? I don't have any negatives, so I'm going to make my axis more like that. Okay, so at negative 1, I'm at 1/6. At 0, we're at 1. Oh, I'm sorry. I'm graphing this function. At negative 1, I'm at 6 and 1/6. Let's make these go by 2, because we're going to have to get 12 on there. So 2, 4, 6, 8. So 6 and 1/6. X is negative 1 is going to be right up there. And then at 0, I'm going to be at 7. 2, 4, 6, 7 is right about there. And at 1, we're going to be at 12. 1, and then 2, 4, 6, 8, 10, 12. All right, so here's the other thing. Normally, our asymptotes for these exponentials is y equals 0. But this has been shifted up 6. So now our asymptote is going to be at y equals 6. I want to plot that because it's going to help me graph. So there's y equals 6. And so this function is going to never cross that horizontal asymptote, and it's going to go up like that. Okay, so here's our normal axis. There's our normal x-axis, our y-axis, and then there's what the function looks like. Remember, we can check these in our calculator. All I have to do is 6 raised to the x plus 6. I can zoom 6 it. Here's what it looks like. You can see it's way up there. It never crosses if I were to hold down trace. It's never going to get lower than 6. I can just sit here and hold this as long as I want. I'm never going to go past the 6. Eventually, it even starts saying 6 just because it's so close, but it doesn't know what to do. All right, so if I look at my table of values, I can check those key points too. There's my 6 and 1, 6. There's my 7. There's my 12. Good shape. All right. Looking at the next one, E is the special number. All right. If you forget what E is, you can always see what it is on your calculator. It's 2.71. But if we don't know, find E. Well, there it is, right there, by the division symbol. To get to it, I need to push the blue button. So if I want to know what E is, I just type it in, push enter. Here it is. E is a special irrational number, kind of like pi. Pi is the most famous irrational number. E's a close second, I suppose, is 2.7182818828, like that. All right? Now, it actually does not repeat this 18281828 pattern. It looks like it does, but it does not. If it did that, then it would not be irrational. It cannot repeat any kind of pattern. So, anyway, all we really cared about is what is E. E is approximately 2.71. 72. To the nearest 100. Okay, so we're going to make our chart. So if we're comparing X and F, we know if we plug in -1, well, E to the -1 is going to be just 1 over E. So I might want to use my calculator for that. 1 divided by E. That's about 0.37. If I plug in 0, anything with 0 power is 1. If I plug in 1, E to the first is 2.72. Well, now I'm going to think, what would this do to it? Well, that's just going to take all of my x's, and it's going to shift them to the right 4. Okay? So now, all I'm going to do is I'm going to have to add out my columns going this way, because I'm going to have to say that this is shifting all my x's to the right 4. So I'm going to have to add 4. Add 4, add 4. So in this problem, we didn't even need this column. We just needed our new x's. So our key points here, I'm just going to write these out just so you can see them. Our actual key points here that I need to plot are 3.37, 4, 1, and 5, 2.72. So let's see what I need to do here. Yeah. Just go right about there is fine. Thinking about the asymptote, every time I have an exponential function, that asymptote is always y equals 0, unless I've shifted up or down. Here I shifted up, so it changed. But if I have y equals 0 as a horizontal asymptote, and I shift to the right, that doesn't change it. It's still y equals 0. So my asymptote is still just y equals 0. Have that on over here too. It's y equals 6 at the end. So now I'm plotting these points. I go to 1, 2, 3, and 0.37. And I go to 4, 1. And we're at 5. And 2.72. So again, this is our asymptote. Don't go past that horizontal asymptote. Right there it is. So this is just going to go stay down like that, and then zoom way up. If we're a little unsure of our graph or anything, I can put this in my calculator. I can just do E raised to x minus 4. I can do a zoom 6 to graph it. So I can see that it takes a long time for it to get going, and then once it does, then it shoots way up. Looks kind of like mine. Looks good. Look at our table of values. I'm just going to check these. So at 3, we should be at 0.37. At 4, we should be at 1. And at 5, we should be at 2.72. So we know that we are correct. So on your homework, when you have to graph, I do want you to state the asymptotes. Your book will tell you to graph the first one and the second one, but I just want you to graph the second one. If you have graph paper, you can use it. If not, you can just do like a quick sketch, just showing whether it's going up or going down, like that. But I do want to see these key points. Actually, these points are even more important than your sketch. Like, I'll be asking you, what are the key points? So in this case, our key point, first one would have been -1, 6 and 1/6. Next one was 0, 7. Last one was 112. All right, so that's lesson 6.4, the first part of it.